Hello, class. I hope you had a restful and safe spring break. Today, we're going to be talking about rational exponents. So, our objective is to recognize different ways to represent rational exponents and evaluate given rational exponents. So, when we're talking about rational exponents, we have some number raised to an exponent that is a ratio. So, all of this is in the exponent. We have this m over n, and this can be written this way, but it can also be written like this, where we can take this n from this denominator and move it out here, out in this spot on the radical. And there's two different ways to write this. You can write it like this with the m still underneath the radical, or you can pull the m out here. And basically what this means is, these two different ways is, we can either apply this power to the x first, the m to the x first, and then take the nth root, or we could do it the other way. We could take the nth root first and then raise it to the mth power. We can do those operations in either order. Okay, that's all that means there. So now we have some vocabulary down here. So first, the index, that's the root of the exponent. So that's the n value here. That's the root of the exponent. The rational form, that's when we have it as a ratio, the exponent, m over n. Radical form is when we're using the radical symbol, okay? Now, to help you remember what the m over n means, a lot of times you will hear what is known as flower power. And what that means is that the m represents the power. So here you can see I have m and then over n down here. So m is part of the flower, and that's the power. So we're raising it to the nth power. And then the n, see how that's in the root. So in the denominator down here, we have the roots. So maybe this picture will help you remember that flower power n root. So let's go ahead and take a look at some examples where we are representing these rational exponents different ways. So here we have this is in radical form, and we want to go ahead and represent this in rational form. So the 6, that's the power. The 3 is the index, that's the root. So the 6 goes on top, the 3 goes in the denominator here. We have 6 over 3, which can be simplified to just 2. So we can go ahead and simplify this to x squared. Now we have the reverse. We have w, and it's being raised to the 2 over 3 power. And we want to write this in radical form this time. So again, the 2, that's the power. So that's our exponent here. And then 3, that's the root, the index, that goes out in front into the radical sign. And again, you can write this either way. Moving forward, I would probably just stick to writing it this way. But I just want you to understand that we can do either of these operations in either order. We can do the root 3 or raise to the second power in either order. So now we want to go ahead and do the U try number 1. So let's look at the U try number 1. For all of these are all in rational form, and we want to go ahead and put them in radical form. So go ahead and try U try number 1. Go ahead and pause the video and try these 4 parts for this first question. Okay. Here are the answers you should have got for these. So we have x squared, and that's underneath the third root there. This one, you can write it as a to the first power underneath the fifth root, or a to the first power is just the same thing as a. You don't necessarily need to write that 1 there. So hopefully this is what we got for these answers. Let's go ahead and move back to the notes here. Now we are going to try evaluating our expressions, meaning we're going to find a numerical answer for this. So for all of these, I think it is going to be most beneficial for us to write them in radical form. Notice that these are in rational form as is. I think we're used to rooting things when they are in radical form. I think that helps us organize our exponents a little better. So I think it's going to be better for us to do that first. So I'm going to go ahead and first write this example number 3 in radical form. So that will look like this. So we have 8 squared, and that's all under the third root there. Now from here, we have a couple different ways to go about this. Like I said before, we can do these operations in either order. So we can take the third root of 8 first and then square that, or we could square 8 and take the third root of all of that. This one I think is a good example to do the 8 squared first, just to show you how this expands underneath the square root and how we take, or underneath the third root, and how we take the third root of 8 squared after. So I'm going to do that. So 8 squared is really 8 times 8. And I went ahead and expanded this, did the prime factorization of this. So 8 is 2 times 2 times 2 times another 8 is 2 times 2 times 2. Now the reason I'm doing this is because this makes me able to find what the third root is. Since this is a third root, I need to pull out groups of 3. So I can pull out a group of these 3 2's here, and I can pull out this group of 3 2's. So really I end up with 2 times 2 on the outside. 2 times 2 is 4. Okay. So I did it that way because this is, I think, a pretty basic one for us to do the exponents inside first. But I think for most of these, you're better off doing the radical first, provided that it is something that can be perfectly rooted in that way. So let's go ahead and look at example number 4. I'm going to go ahead and write this in radical form. So this time I'm going to take the third root of 27 first and then square it after. So the third root of 27, and if you have a calculator like this, I can show you how to do that in the calculator. Type in 3 first and then second, and then this button right here, that's where you get different kinds of radicals. And then inside we could type 27. So the third root of 27 is 3. So if you didn't know, 3 times 3 times 3 is 27. So I can say that this, I can say that this is really just 3 squared, and 3 squared is 9. Okay. This next example is a little more complicated. We have 9 to the negative 1/2. Now, once we start combining negative exponents and rational exponents, I think there's a lot of room to get confused there. Don't forget that negative exponents means we need to move this whole thing to our denominator to make our exponent positive. So I'm going to go ahead and do that now. So here, instead of having 9 to the negative 1/2 in the numerator, we move this to the denominator, and now we have 9 to the positive 1/2. And now we can write this rational exponent as a radical in radical form. So now we have 1 over and then 9 to the first power, and this is being square rooted. So 9 to the first power is just 9. The square root of 9, that's one that I hope we are familiar with. The square root of 9 is 3. So this is really just 1/3. So this 9 to the negative 1/2. Really, this just simplifies to 1/3. Now 6 and 7, you may realize, are somewhat connected here. Now I hope we are familiar with the fact that when we have a negative out in front here, the exponent does not apply to that negative unless this is all and parentheses. So let's check that and see if we get different results for 6 and 7. Again, first thing we want to do is write these in radical form. So let's focus on 6. Let's write it in radical form. So this negative should be out in front like this. None of the exponents apply to this negative. So we have the negative out in front. The exponents just apply to this 8 value. I think it is best to, again, third root this 8. The third root of 8 is 2. And then 2 raised to the 4th power is 16. Again, this negative is out in front here. This 4 does not apply to the negative. So we have this negative, and then 2 raised to the 4th power is 16. So really we have a negative 16 there. So here in 7, we have the negative inside this rational exponent. Let's go ahead and see how that affects our answer. Once again, we want to write it in radical form first. So now we have the negative inside the radical. So we want to, again, take the third root first. The third root of negative 8 is going to be negative 2. Negative 2 times negative 2 times negative 2, or negative 2 to the 3rd power, is going to give us a negative 8. So now we have this negative 2, and this negative is inside these parentheses. It is being raised to this 4th power. So we have to think about what negative 2 to the 4th power is, and that's going to be a positive 16. So notice when we had the negative inside versus outside parentheses does actually affect our answer. Okay. So let's go ahead and now look at number 8. Number 8, we have a variable base. We don't have a number base, and this is being raised to the 2/3 power, and then all of that is being raised to the negative 6th power. So we have to think about what happens when we have an exponent raised to another exponent. So I would recommend simplifying that. Remember, we have an exponent raised to another exponent. We need to multiply these values together. So I'm going to go ahead and do that. So 2/3 times negative 6. We just need to multiply the numerators there. So 2 times negative 6 is negative 12. And then 3 times, this is over 1. So 3 times 1 is just 3. Now negative 12 over 3, we don't need to write this in radical form now because this actually simplifies. Negative 12 can divide by 3. So I'm going to go ahead and do that. So negative 12 divided by 3 is negative 4. And again, when we have a negative exponent, we want to move that to the other side of the fraction. So this moves to the denominator. We have 1 over x to the positive 4. So that's what we do when we have exponents raised to the exponent. Last example here before we get to the last you try. This one is a similar type of problem, but now we have a number base. So again, I'm going to go ahead and multiply these exponents together. So 2 times 9 is 18, 3 times 1 is 3. Once again, we don't need to write this in radical form because this does simplify. 18 over 3 simplifies to 6. And then we have negative 4 raised to the 6th power, which you can put in your calculator, is 4,096. So last thing we need to do here is go ahead and try number 2. So get the you try paper back out. Let's take a look at number 2. I'm going to go ahead and pause this video. I want you to try these on your own. Pause the video and try these on your own, please. And here are the answers for the first two. I wrote these in radical form, and I did the radical before the exponent here. So I square rooted this one and third rooted this one, and then applied the power. For C and D, I multiplied the exponents and then simplified the rational and then moved the negative exponents to the denominator. If you have questions about this or questions on the homework or anything on the notes, please come to mine, Miss Claywell's, or Miss Parsons' office hours, and we should be able to help you there. I hope you are all doing well, and enjoy your time.